Here we are with the short overview of Unit 3. So to situate us in the year, I'm going to hop to the slide that shows the Energy and Engineering unit. Here's all the patterns that we encounter in this unit, and you can see two critical performance expectations around conservation of energy and using computational models to track it through a system, and then also using simulations to model the impact of proposed solutions to a real world problem. All right, so you can see this builds up to student skills so that they're ready for the increasing performance expectations that are coming. All right, so back to the main website, you can see we spent about 6 units on this, really critically important, and there are several assessment opportunities, quizzes, labs, troubleshooting with engineering, and the engineering portfolio. So this unit is themed on students making a bungee jump app for a real bungee jump with water bottles and stuff that they'll do right in the school. So to do the 30-second overview, they first have to learn how to track energy. Then we spiral the system analysis that they did in Unit 2. Using that guides them the rest of the way. They figure out that they need a mathematical model for gravitational potential energy and elastic potential energy that they then use to code in their upping their game with their spreadsheets and coding within that to model this more complicated system, and then ultimately do a real jump, possibly with administrators, other teachers, and even community members and parents. All right, so the few highlights that we're going to show in the short one is we really take on the engineering cycle this time, scaled up from Unit 2. So they, again, start with what they're really trying to do. Then diving in, they use the tools of science as a pre-write, the NGSS in one sentence, use the big ideas of science to explain phenomena and solve problems. They do both of that in this unit. So they're using the big ideas here to explain the basic physics of a bungee jump. And they do that through actually using the tools of science to track the energy flow. And then they annotate it. You'll see that in the slides. And then that is the pre-write. Basically, we tell them, explain, lead with the big idea of science, and then explain your annotation. You'll see that in the slides. It's not here on the answer key. Then they take a deeper dive into what is required by the amusement park that they need. And it is meant to be a little bit overwhelming at first, but it's really just one page. And from that, they go through and they up their game with system analysis. That's spiraling a little bit more sophisticated now that we're coming back, and they've already learned how to track the energy. And then after reading that one page, they realize what they need to get, which a lot of this is just straight measuring with a tape measure, but there are a couple critical ones where they need mathematical models. So of course, that's what we're going to do. They're going to go and do a POGIL-like activity to get the mathematical model for gravitational energy, and then they need it for elastic energy as well. So I'm going to skip ahead to that one and just talk about how an analogous system of study. No, we're not going to go measure people bungee jumping. We're going to have an analogous system of study, as we so often do. And again, here is a small scale system analysis of the bungee jump. They again track the energy and they can figure out that the elastic energy is the difference of the starting gravitational energy to the ending gravitational energy. And then they can use that to actually code their data spreadsheet in their lab. And then putting it all together, of course, we have a data discussion with a card sort, and they walk the triangle and explain why the constant, how the constant shows up, and why it makes sense that this is quadratic. Then having all of our pieces together, they also need to get the spring constant with a quick Hooke's Law lab. They now have everything they need to actually code that system analysis. And it looks very much like their system analysis on paper, including generating bar charts at several different heights of the jump. And then they're ready for the big day, which is super fun. There are highly structured interview questions for adults that are attending the App Expo. They also have a peer evaluation of their teammates to do. Then, of course, their talking to those adults if you choose to do that. And then they're going out and jumping after having prototyped and tested jump. That's all worked into the engineering portfolio. And of course, there's accompanying slides to help with that. There's even some fun awards and signage for the jump day, all around having it be a great fun day. If you do go into a second day for it and you want, some students need an extension, there is a redesign where in light of a lot of ankle injuries, they got to redesign their jump cord, and that just gives you time to work with students that need more teacher attention. So that is our short overview of Unit 3.